Look up on a clear winter night, and you witness abundance. Orion's belt. Andromeda's gauzy blur, the faint snow of the Virgo cluster. Yet all this splendor is slowly retreating behind an invisible curtain. In the mathematics of an accelerating cosmos, there exists an event horizon. A radius beyond which light launched today will never, not in infinite time, reach us. At this moment, that boundary lies about 16 billion light-years away. But every second dark energy tightens its grip, inching the horizon inward in moving terms like a slow-closing iris. Meanwhile, gravity knits a final redoubt. The Milky Way and Andromeda are already on a collision course. In 4 billion years, their spiraling dance will forge a single, giant, informally dubbed Milkdromeda, surrounded by a halo of dwarf satellites. Outside that enclave, even the nearest groups will slip past the horizon, their starlight stretched until galaxies fade to ember-red ghosts, then to silence. Future astronomers, peering from within Milkdromeda's glittering core, will see an apparently static universe. No Hubble flow, no cosmic microwave background bright enough to detect, only their own wheeling stars. They will live on an island universe, much as 1920s observers once mistook our galaxy for the whole. The irony is profound. While our grasp of cosmology grows richer, the accessible cosmos itself is shrinking. Inertia continues to fling clusters along their geodesics. But the fabric beneath them swells faster still, erasing destinations from every map. The grand theater endures, yet its audience will someday sit in near darkness, hearing only whispers of an act that once spanned billions of light years. Out beyond the Kuiper Belt, a compact car-sized craft built when disco topped the charts is still coasting outward. Voyager 1 carries a gramophone record of whale calls and back, its plutonium heart whispering 20-watt radio syllables back to Earth. The Deep Space Network's dishes, sensitive enough to hear a fridge light bulb on Saturn, strain to catch those whispers, already a trillion times fainter than the hiss of cosmic microwave static. Sometime around 2036, the plutonium will cool, transmitters will fall silent, and Voyager's voice will fade into the radio night. But the probe's journey has only begun. In 30,000 years, it will pass within 2 light-years of a dim star in Ophiuchus. In 300 million it might cross the outer rim of the Milky Way. Yet even this faithful emissary cannot outrun the expanding stage. Calculate its path on a metric that accelerates, and you find a bittersweet truth. Voyager will never breach the future event horizon. Its inertia is mighty, but the cosmos's swell is mightier still. The probe will asymptotically approach a boundary that itself recedes like a swimmer forever shy of an unreachable shore. Radio waves too languid to propagate, the craft will become electromagnetically invisible. A tiny silent arc, drifting through an ocean whose very fabric outpaces light. Yet for as long as atoms endure, Voyager will bear testament to motion's stubbornness. A relic of a civilization that sensed its cosmic shore receding and, true to human form, launched a bottle anyway, hoping motion itself might carry a message where voices cannot. A starship launched 2 centuries from now will drift through space that does not sit politely still. Each kilometer it travels today will be fractionally longer tomorrow, stretched by dark energy's silent breath. Traditional charts fix constellations, inertial reference frames grow unreliable when the stage itself expands. So, cosmic wayfinders are turning to nature's most precise metronomes. Millisecond pulsars spin hundreds of times each second, their radio pulses as regular as atomic clocks. By triangulating the arrival times of half a dozen such beacons, a spacecraft can pinpoint its position to tens of kilometers anywhere in the Milky Way. Yet expansion tugs even on those timings. Pulse intervals drift redward ever so slightly as spacetime swells. Navigation software must fold in a living term, correcting course with every nanosecond beat. Fast radio bursts promise an even farther-flung compass. These millisecond flashes now erupt daily from galaxies billions of light-years away. Their dispersion measures the amount of ionized gas, and hence distance between emitter and receiver. A future vessel could treat each FRB as a lighthouse flickering on the cosmic shore, updating its coordinates against the shifting metric. All the while, onboard chronometers tick a different tale than cosmic proper time. The universal clock defined by the average motion of galaxies, After centuries in cruise, ship time and cosmic time part ways by minutes than hours, a relativity lesson writ large across interstellar logbooks. In a universe that stretches underfoot, to know where you are demands knowing when you are with equal care. Each correction, a quiet acknowledgement that motion is forever negotiating with geometry's restless sea. Human ingenuity has always answered distance with speed. The O-Earth slingshot steals kinetic bounty from giant planets. Solar sails borrow photon momentum. Fusion concepts like Project Daedalus promise 10% lightspeed dashes to nearby stars. But the accelerating universe moves the goalposts even as we lace our running shoes. Launch a 0.1c craft toward Andromeda today, and after 2 million years the galaxy would greet it barely. Wait 10 billion years and the same delta V cannot catch up. Andromeda's recession surpasses any speed reachable without exotic physics. In the far future, even laser-pushed light sails, clipped close to sea, would find targets receding faster still. Like arrows loosed at a bullseye that sprints away the moment the bowstring twangs. Gravitational assists, once the clever mariners cheat, fade too. As local groups merge into a single elliptic giant, slingshot options dwindle. No Jupiter awaits outbound Voyagers, only the mass we carry and the photons we harness. Generations may learn to ride dark matter wakes, the diffuse halo enveloping Milky Way Andromeda, skimming potential wells left by annihilation hotspots. Yet each hack confronts the same ledger. Delta V buys distance, but expansion charges compound interest. Infographics of the reachable radius tell a sobering story. At cosmic age 0 gigayears, a 0.1 C drive spans 2 million light-years. By 50 gigayears, dark energy squeezes that bubble to a few 100,000. The universe is turning into a vast treadmill. No matter how hard we sprint, the rubber beneath runs faster. Still, the urge persists. Perhaps propulsion will pivot inward, building O'Neill's cylinders lush with forests, or simulating entire biospheres in quantum processors. Journeys not of kilometers, but of cognition. Motion will endure, but the destinations we chase may become interior realms. Proofs that exploration outlives the maps it redraws. When destinations slip away faster than rockets can chase, the next frontier may be memory itself, carving messages hardy enough to outlast the widening dark. Engineers have already etched libraries onto human hair, thin slivers of sapphire and fused quartz. Their nanoglyphs readable after 14 billion years of cosmic ray peppering. Yet even sapphire will orbit a star, destined to redden and shed its skins. So designers are eyeing colder sanctuaries. One proposal dispatches graphene wafers at Omthin, nearly unbreakable onto sentinel-like orbits far beyond the Kuiper belt. There. Temperatures linger just above absolute zero, and impacts are rarer than supernovae. Each wafer bears genomes, star charts, prime numbers, breadcrumbs for any mind, human or otherwise, that might arise inside Milky Way Andromeda's future dusk. Other teams think bigger, encoding chronicles and the polarization patterns of single neutrino bursts. Fire a precisely timed train of gigaelectronvolt neutrinos toward a millisecond pulsar, and its magnetosphere will scatter the signal for eons. Only a civilization with neutrino telescopes could decode the staccato prime factor cadence. For still grander ambition, theorists imagine modulating a gravitational-wave beacon, nudging a tight pair of white dwarfs so their orbital decay taps out Morse in the fabric of space-time. An inscription immune to dust, darkness, and even the demise of ordinary matter. Closer to home, a proposed long-time observatory would anchor ultra-precise optical clocks to the moon's far side, recording tick by tick whether dark energy drifts from its measured value. The logs could run for trillions of years, long after Earth's oceans steam away, offering future physicists a baseline older than their stars. In every plan glows the same impulse. If travel falters, let knowledge roam, carried by particles and waves that expansion cannot erase. We have watched the horizon tighten, charted starships that can no longer catch their quarry, and designed runic messages meant to outlive suns. Yet through every twist of cosmic fortune, one conviction survives. Motion itself never wanes. Voyager glides on. Photons depart receding galaxies. Virtual particles quiver in quantum dusk. Even when destinations vanish, trajectories persist. Lines etched into a canvas that stretches without bound. Human ambition will adapt. Some descendants may seed entire biospheres inside kilometer-wide cylinders, orbiting the merged core of Milky Way Andromeda. Others might digitize their dreams, surfing processor cycles sustained by captured starlight. Explorers will map inner worlds of thought, mathematics, and art expeditions measured in ideas rather than parsecs. And still, in every turbine spin, in every neural flash, inertia whispers the same refrain. A body, a signal. A pattern keeps to its path unless coaxed aside. As we step into the outro, motion never dies. We will gather the saga's threads, Newton's apple, Mach stars, LIGO trembling mirrors, supernova flashbulbs, and the silent thrust of dark energy. We will ask what it means to live in a universe where absolute rest is myth, where expansion outpaces intent, and where the truest constant is the relentless unfolding of trajectories great and small. So take a breath and feel Earth's spin, our orbit, the galaxy's drift, the cosmic swell beneath it all. The stage will keep expanding, but the dance in every quark and quasar goes on. In the final reflection, we'll celebrate that eternal choreography and set the brush down on this cosmic canvas, knowing the picture itself will never hold still. Pause for a moment wherever you are. Feel the quiet tug of gravity, the breath in your lungs, the faint hum of distant traffic or wind. By every human measure, you are at rest. And yet beneath that hush, Earth is turning faster than the muzzle velocity of a rifle, swinging around the sun at 30 kilometers a second, spiraling with the Milky Way through a halo of dark matter, and surfing an expanding fabric that adds new space between galaxies even as you exhale. Stillness, we discover, is a local rumor, not a cosmic fact. Our journey began with Galileo and a creaking ship's hold, showing that uniform motion leaves no footprint on the experiments we perform inside. Newton chiseled that intuition into law. A body keeps its motion straight and steady, unless a force petitions for change. Mach asked whether distant stars might write that law in the first place. Einstein answered by folding inertia into geometry, letting free-falling apples, orbiting planets, and traveling photons trace geodesics on a pliant canvas of spacetime. We followed that canvas as it stretched, first coasting, then accelerating, driven by a pressure hiding in the vacuum itself. Supernova flashbulbs, acoustic fossils, and faint lensing shears all testified that the universe has pressed the accelerator and will not release it. Ahead of us lies an age, when only our merged local group lights the night. Beyond that, a long blinking out of stars. Motion, however, will persist. Voyager will glide in radio silence. Photons will redshift into whispers. Quantum fields will jitter with irreducible uncertainty. The very notion of absolute rest will remain as mythical as the still center of a hurricane. How, then, do conscious creatures respond? Some will chart new realms of propulsion and navigate an inflating sea. Others will bind memories into sapphire wafers, neutrino pulses, or the creaking orbits of lunar clocks. Perhaps the greatest voyages will unfold inward into art, mathematics, and shared story. Worlds where distance is measured not in light years, but in insight. Whatever course we choose, inertia is our eternal companion. The promise that trajectories once set endure. Even as the cosmic stage expands beyond reckoning, the dance itself will never cease. Motion is the canvas. We are the fleeting brushstrokes. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking. Keep looking up, and never stop wondering.